I want to introduce to you today's topic. It's about CNC programming, and I've combined what we call subtractive uh, machining and also additive machining. When you say subtractive, you are removing material, but when you say additive, you are adding material. Let's say think like 3D printing aspect where you can produce parts, but those 3D printing they are also use what you call the G&M codes. So our main objective is to understand what is computer numerical control, because in our channels we normally give you videos explaining how to program, but maybe we need to understand initially what is a part program before you go to computer to help you in programming. Let me introduce to you what you call part programming or CNC part programming. What does it mean when you say CNC part programming? Okay, for people who have been using C++ or C Sharp or Java, whatever language, Python, whatever language you're using to program, in our machining language, we call them programming because we're using what we call word programming language, for the front end, not the back end. So in our front end programming, when you say CNC, CNC stands for computer numerical control. Computer, which means if you're using a computer, it is like a CPU. It has power to allow you to input, to process, to give you an output, also to retrieve data at any given time. Then when you say numerical, which means, for example, if you have G40, this G is an address, then 40 is a digit. When you combine these two of them, they become a word. Then when you put many words together, they become a block. And then when you put very many blocks together, they become a part program. So in our essence, when you say computer numerical control, you are using numerals, which has been programmed using either CNC or using PLC to control the movement of machine, so that it can allow the machine to shape the part into desired product, which means that you have to either design the part, and then you have the machine that can do that one. Remember putting into mind what you call the tools. So in our introduction is we want to understand what is part programming and what is CNC. So CNC is just a computer numerical control. You are using numerals that have been programmed as a set of instructions to give or to control the movement of machine from maybe from one point to another, while shaping the part to desired features or desired output. Normally, in a part program, normally there is normally called the part program, which means you program a single component. If you have many parts together, you program a single component to give you that part. So that many parts, when after machining, you can assemble them to give you an assemblage of or sub-assemblies of the parts. So when you say part program, you are creating a set of instructions to control the machine table, or to allow or the machine to automate the process of shaping the parts you want in desired shapes. So in our case, we will be looking at operations. We'll start with lathe operations, then we'll go into milling operations. So today we will be introducing on what we call milling operations, like external turning operations and internal turning operations. When you say in external turning operation, you have things like side and face grooving. Side and face grooving, we'll be explaining that one in details. We have what we call step and taper turning. We also have what we call contour turning. We have part of cutoff. We have nailing. We have for internal, we have boring and drilling. When you say drilling, you are making a new hole, but when you say boring, you are expanding already existing hole, which means this one I normally refer to a virgin. This one I normally refer to somebody who is not virgin. So which means already if it is virgin, you are expanding this one using what you call boring. So in simple language, we call it boring. We are expanding already existing hole. Then you also have what you call internal grooving. You can also create a groove inside. Normally, these operations help in different aspects. Like if you're making a shaft that has grooves, grooves can allow maybe insertion of O-rings for prevention of leakages in most of the automotive and mechanical components. We will also learning about threading. Like, remember, we also have external threading and internal threading. We learn how we can create what you call um, um, one start to four start threads. Also, internally, we have what we call step turning, taper, and contour turning. And in most cases, the purpose of these machines is to shape the workpiece with precisions so that it can give you the desired output. So, welcome. Let's move one by one. Okay, before you do what you call a programming, if you're using manual part programming, remember we have different languages we can use to program your machine. If you want to program, first of all, the one condition you need to check is the workpiece. The workpiece is the part you want to, let's say the target, the part you want to machine. But that part you have to check on the major diameter and the minor diameters, and also you look at the approximate length that you need to use so that when you clamp on the machine, it's able to hold on the workpiece and it is able to give you the desired part. Because CNC machining, we are using what we call subtractive machining. If it is subtractive, meanings that the workpiece, the stock you're using should be more than the workpiece, but not too big, so that you minimize on wastage of time and also wastage of materials. Also, you need to look at the material properties, the material that may allow you to use coolant, others may not allow you to use coolant. And also, things like the depth of cut, the spindle speed or cutting speed, the feed rate, all these parameters will help you to understand how you select them for the optimal cutting condition so that you're able to improve the tool life. You also improve the surface finish. So material properties is very important when you want to program. So this is what you call pre-programming checklist. I normally call it the planning. So you in your planning, ensure that you check the workpiece you have, you check the material you're working with. If you're working stainless steel, mild steel, brass, copper, the amount of feed rate you use, or the depth of cut, or the cutting speed, or let's say the cutting parameters may be different depending on the material. Even the tool requirements, some may require the HSS we call it high speed steel, or you can use carbide or tungsten material, which are normally either PVC or CVC coated. So you need to also to understand that the material properties may affect the tool requirement. If your material is hard, you need a tool which is more harder than the rest. Normally, we have what we call the HRC hardness for the tool from 45, 50, 55, 60, like that. So you need to select the hardness of the tool depending on the hardness of the material. The tool hardness must be more than the hardness of the material you're working with, so that because it is metal cutting against metal. Then you also look at the operation sequence and also the relevant cutting parameters that you need to optimize to give you the desired output. When I say operation sequence, let's say grooving or parting off or threading, which operation can you start with to make it easier when you progress on the next operation, and the final operation, it doesn't affect the surface finish and it doesn't complicate you when you are cutting. So you need to look at the proper logical sequence of operation that you select, and also the proper cutting parameters for each operation. If you're using grooving, parting off, threading, step turning or contour turning, the kind of feed rate you use, the simple speed or cutting speed, or even the amount of coolant you allow, either through the tool, if it has a through tool or not through tool. So you need to have in mind these are the key parameters you need to counter check before you also program. And even the critical part is on the machine, because the machine has the capabilities. You when you select the powerful material or the machine that you have, or even the controller, the output will be fine. The output will be so fast when you are machining it, and even the programming language will be easier for you to interface. So there are many factors we can consider, but today we can look at what we call workpiece parameters or workpiece dimensions, material properties, tool requirement, operational sequence, and cutting parameters. We can look at these factors. Then in terms of manual part programming procedure, um, I've just simplified the programming procedure we can use. Simplest for you guys, for example, If you're using manual part programming, because you have two methods you can program, you have what you call manual part programming, where you input the program manually, and you also have what you call computer assisted part programming. In this era of advanced, like let's say you are using controller 840D, it has capability to do what you call shop turn. Most of the Siemens machines, if you're using Siemens controllers, are advanced from either to 828D, 840D, and numeric 1. They have advanced controllers where you can you can use what you call shop turn and conjure editors to program your part, where you give in the parts, then it generates the conjure automatically for you. So it has its own language. But for our case, if you're using maybe a machine that maybe like they say a lathe machine that has two axes, where you are programming manually without all those capabilities that it has. So we're able to understand the procedure, and normally the sequence of operations in terms of manual part programming is one, you need to have a file. You can use a CAD design softwares, let's say like Inventor, SolidWorks, Creo PTC, maybe Fusion 360 or FreeCAD to design your part. Then that part, if you're designing it for machining, you have to consider all parameters, all tolerance, all surface finish in a symbol drawing. Let's say this is a symbol drawing you want to use to send to the shop floor. The person who is in charge in the workshop, maybe now the part programmer, able to program and then machine the part. So the first procedure that is very critical is how do you interpret the drawing you have designed in terms of the dimensions that you have, in terms of the cutting parameters, surface finish, and also the geometry required. So the first stage is one, the designer has to create a part in CAD software. Second is you have to generate an orthographic view drawing or a symbol part programming, a symbol drawing for part programming. Then the person who is to program must interpret the drawing first of all, understand all those parameters, let's say like the dimensions, workpiece dimensions, things like material properties of that drawing, the tools you require, and how you're able to sequence the operation. Then from there, you can generate what you call um, program manual script. The program manual script. First of all, before you generate a program manual script, you have to understand the language of programming, like interpolation, different types of interpolations, different types of spindle speed, tool function, feed function, preparator functions, miscellaneous functions. All of them you have to understand before you now generate what you call a program manual script, because it is like a sheet. You put in all those parameters, X, Y, Z, tool, cutting parameters, then you transfer that program as it is into the machine using what we call machine control unit. In a machine control unit, I'll show you something like this one. Maybe this is a control unit, which is allowing you to interface input of the program into the machine. Somehow it may look like, maybe they say this one, you may have something like this. You want to input the program. This can now be your machine control unit. It allows you to input the program just like a normal computer. You input the program into the machine. So as I said, that machine is a computer because it has all those capabilities to allow you to input the program using all the keys in that control unit. Then from there, you can do what you call setup. The third step is you need to do what you call setup. You set up the part origin. What part origin are you using? Are you using machine coded system? Are you using workpiece coded system? If it is from G54 or G59, you can select some that you want to use depending on your machine. And then once you set up the part origin, either using G54 to G59, you need to verify the program through what you call simulation. You click on the simulation, then you verify. I will explain this one when you go now to a simulator. We'll be using a simulator in the next episode so that we can run a simple program. We learn how we program, then we simulate the part program. We see how it works and where it gives us the error, then we troubleshoot. When we do this one in step one by one, with 1 week to 2 weeks, you're able to become a master of manual part programming. Okay, then once you are certain that whatever you have done is correct, you have done a setup, you have done a simulation of your part program. Others can do what you call dry run. You're able to do dry run, meaning you remove the workpiece and the tools, and then you do a virtual setup. you now run the program, you see how it behaves when it's doing what you call a dry run. Okay, once you are satisfied that whatever you have done is correct, you can now do what you call auto run, or you can use a single block to run your machine so that it can give you the output. But before you dispatch a product from the machine, first of all, you can check what you call the dimension accuracy, tolerance required, and also surface finish. So this is a simplified program or procedure for what you call manual part programming. But if you're using a software, then this one doing this one will go off. Like this part will go off because you just program using the computer, then you generate the program, you put it into a machine, then you transfer sorry, you put into your flash, or you can use LAN cable to transfer to your machine. So this is a simplified procedure for what you call planning and preparation of your program. I want to venture into what you call a root cause analysis. I've come to realize, like in Kenya and Africa, there are very few machinists and part programmers. And when you look at most of our colleges in Kenya, let's say use Kenya because I'm in Kenya, most of our colleges, they may have these machines, but they don't have the actual course that only designed for CNC. You may find they have a course inside, they have put CAD, inside they have put bench drawing, inside they have put production. But as an expert, these are skills which are paying in industries. Things like CNC laser, you're using laser, if you're using plasma, if you're using water jet, you're using 3D printing, CNC lathe, CNC milling. Some of these skills are high paying in industries, and they are cornerstone of most of the production. But in colleges, we don't have this specific course for laser machining, plasma machining, jet machining, lathe machining. They only offer conventional machining, but when you come to CNC, there's a very big gap. So I did my root cause analysis. I wanted to understand why we have this gap in terms of the CNC and compared to the modern challenges that we have. Maybe during those days, they were using the ANC machines, but the technology has advanced. If you look at the equipment and the material that is needed, almost it contributes 19 to that's almost 19.5% in terms of the failure of a qualified CNC expert, which means as a CNC expert, you need to understand the technical aspect of the machine and also the maintenance aspect of the machine. Not necessarily that you master all of them, but you need to have basics in terms of the technical maintenance aspect of the machine. So this one is a job on itself, which means if we have workshop, yes, if we had these skills, these courses being offered in our TVET or if being offered in our universities, one factor is you at the end of the day, somebody may become a technical machine maintenance expert specifically for CNC lathe, CNC milling, laser, plasma, and water jet. But still we have a gap. Many people, actually many colleges, they have the machines, but they don't have this expertise. So when the machine breaks down, it is covered with a tent. When you go to these colleges in Kenya, you find these problems. Next is about procedural problems. I'll explain procedural problems like the required procedure in terms of creating a part program. Many colleges or many experts who are in industries, they normally want to understand one fact, let's say one skill, and then they jump. They want to just jump. Maybe somebody wants to just only program. But as an expert, when you learn the basic of training strategies from conventional programming to computer-aided programming, and then inputting or incorporating the aspect of design and also material, you may become a qualified expert in terms of as a CNC part programmer or machinist. So here we require best training strategies so that people can be given the actual skills to become expert instructors or even machinists or even programmers. So this one has almost 23%. When you look at human errors, actually our ignorance in terms of CNC operators, as CNC operators or programmers, somehow the errors that are caused in terms of giving the quality output are caused by human, which means at some point there's something they missed in learning. So when you learn in the right procedure, when you learn the things that are also changing with the modern technology, you're able to minimize these errors. Incorporating manual part programming, understanding all the G codes, and also bringing in the aspect of computer, it will help you to minimize those errors. This one you see have a problem. When you look at training efficiency, there's a very big gap in terms of training that is happening in our colleges. We have the machines. Machines are there. Most cases, I think they were supplied by most of the Chinese companies, like the 2-axis. Yes, machines are there. Somebody, maybe one college was supplied with a GSK machine, another one was supplied with Fanuc machine, others were supplied with Siemens. But when they come together, maybe during a training, they were trained on how to use maybe HNC controllers, the HNC controllers which are modified GSK. But at the end of the day, when they go back to their colleges, these things are missed out. Somebody says, I cannot operate a Fanuc, I cannot operate a Siemens, I cannot operate a GSK, simply because they are different controllers, but he was trained on different controller. But this is part of the deficiency that most of these skills are being misused. As a part program, or as a programmer, you need to correlate all these skills in terms of different controllers. So there is a need to educate people, to train operators so that they be with the proper training technologies or strategies to modernize the techniques and also correlate or integrate with the changing need in terms of machining. When you look at management, maybe you have a company, they are producing their parts, but somehow maybe the managers don't understand the machines. So almost 9.5% may affect the output. So which means as an institution or a company, even the managers need to have basic knowledge about machining so that they don't make those errors when they are executing the mandate of a company in terms of machining. When you look at external factors, things this is minimal, like 1.5%. Problems like maybe power. Most of the machines that maybe are supplied use 3-phase, but when you find that maybe a college has only a single phase, now the machine will be dumped in the workshop. They wait until the case power comes, or they wait until the government does the installation of the 3-phase, and that's a problem. So what is the solution? The solution is very simple. Most of the companies or most of the colleges in Kenya, they have failed to do what you call need analysis. What do they need? What do they require in their training? You don't just supply machines, you give them to use, but maybe if there's no power, you can opt to use single phase machines, which are very lenient, which are very simple, which consume less power. Or you can ensure that people are trained, understand the material procedure or the personal issues of the operators. So some of the factors that maybe contribute are that of the external factors are this, which also affect the machining. When you come to design, actually design, most of machinists that were trained during all days, they were using manual part programming. In terms of design, there's a problem. So 9% of the problem that are affecting the modern industry in terms of machining is coming from also from what you call design problems. So people ignore, like actually most of people they ignore, they don't take designs as serious. They just want the output, but they remember the output depends on the design. Okay, if we analyze this, we'll go down, we check how can we rectify these problems before we now start part programming, because you may need to buy a machine, then at the maybe after 1 month or 2 months, then say this machine is not paying. But what was the main objective? So these are some of the factors that are contributing to the challenges we are facing in terms of machining. Okay, in these challenges, maybe this one I will just try to expand it in layman language, but no problem. So when you look at the previous one, like let's say which one has highest percentages, if we look at on average, if we take these factors, maybe one, equipment, material failure, procedural problems, human error, training efficiency, and effective management, almost 80% are cost and affect what? The industries. So we need to change the game in terms of machining. And things are changing. Like if population is growing, many colleges are coming up, they're offering vocational skills, but still there are challenges which are coming up in the industries. One, at the end of the day, the industries which are using the latest technology, they are lacking experts. And also, we don't have the required training centers. Not even not required, they qualified with the expertise that can offer these skills. Because we have overlooked skills like CNC, the turning, CNC milling. Let's say in Africa, most of these skills have been overlooked, but they are high paying industries in developed countries and also in Africa. If you want to automate production of parts like automotive, you need to understand this language because the world now is changing technologically. There are things are changing in industries. So how do we rectify these problems? There, which means there is opportunity in terms of job creation. If we have colleges offering these skills and the companies are coming up using CNC laser, CNC plasma, maybe water jet, CNC milling. One, there's a job creation. We're able to create jobs. If jobs are created, then it can help us to boost our economic growth. And at the end of the day, when people use this machine more often, it helps to advance our training strategies because the companies will now need more experts, and this one will help us to design more training strategies in our colleges. When you look at these challenges, like in this development, like let's say now in terms of industries, the resource has been strained in terms of when the population grow and we are not innovating more ways of creating jobs, we are overlooking things like CNC laser, CNC plasma, CNC water jet. When you go to industries, most of these skills are there, but when there is more graduates going in industries, but they are lacking these skills. So how do we ensure that we balance the population growth? Because once the population grows, let's say there are more graduates, we restrain our available resources. Okay, challenges like automation and globalizations. When you look at the global stage, most of the companies are even at higher level. Like most companies are using, let's say in CNC. Happen to see the DMG model, they're using numeric one. So advanced, even the robotic are being used in CNC machining. But when it comes to our continent, is yes, it's not that we are not capable, we are capable, but we have misjudged the aspect of the skills that this youth can give. If you allow this Gen Z and the proper ways of training them, giving them the skills, actually they can create employment, they can create opportunities, and we're able to create economy to help their economy grow. Also, there's shortage of experts, skilled experts in terms of the CNC laser, yes, CNC plasma, CNC water jet, lathe, milling, and even 3D printing. Where in our continent Africa, let's say Kenya, where are they offering these skills? Where are they offering? None. But the industries are growing up in Kenya. People are using laser, plasma. Where are they getting experts? Some of them are importing experts from other countries. So what is happening with our vocational colleges? We need to ape our game. We need to change how these skills are very important. Somebody can learn business course for 4 years. At the end of the four years, he doesn't know anything. But these courses doesn't require a lot. Doesn't require a longer duration. Only a maximum 6 months, somebody has become an expert in terms of these skills. So there is opportunity for our country, our leaders to create more opportunities for this. That's why we as Dalcreams Technologies, we came up with this method so that people can come to a company, we offer them what we're able to access. But when they go to industries, they're able to do more and help the country grow in terms of economic growth. How do we address these challenges now that we have looked at these challenges uh, um, affecting our industries in terms of the CNC machining? Because we have overlooked the CNC machining. It's like it is not a skill, it's not an occupation, but the industry has changed. Technology has changed. So one way is we need to invest in our education. We must have government and industry collaboration so that they're able to come together and strengthen our technical training systems. They have to train the trainers with the relevant skills before they train the trainers. If now the companies want to upgrade their colleges with relevant machines, they need to look at experts, need to look at need analysis, capacity building, so that when they have the required skills, when they have the required machines and the capacity to do that one, then we're able to come up with simplified programs or vocational courses that we can offer to our generations. When they graduate after 6 months, they're able to do miracles in the industries and we're able to create employment. When we look at like our training centers, I've not seen a training center offering these skills in Kenya. Most of them are taking them as part skills. In let's say like when you go to our university, like the former Technical University of Kenya, it has a lot, but are they using the machines to the right way? Most of our vocational colleges in Kenya have these machines that were supplied by during Kibaki era. Are they using these machines? Have they expanded the training centers to address these challenges in the industries? No. I will come there, we'll explain. We need to also adapt to technological changes. How technology is changing, we need to also adapt. Most of our colleges are still using AutoCAD to design. Yes, AutoCAD is good for drafting, but when you integrate the aspect of CAM into, let's say, when you want to program using on CNC laser or CNC plasma or jet, somehow there is a mismatch. The technology they are using is actually, let's say, archaic. How do you call it? It is more of traditional. So we need to adapt to the changes in technology. If the company are using Mastercam, if the company are using or maybe Inventor, SolidWorks, SolidCam, HSM, we need also to adapt to those changes so that we remain competitive and we allow automation and digitalization of manufacturing in our colleges, because we are able to do that one. Also, we can do what you call private public-private partnerships. Maybe we can identify companies like Fanuc Company, maybe GSK Company, DMG Mori, and other companies which are have latest technology in terms of these skills, so that they can come into play. They help our training institutions. They bring in dual training aspect. Maybe we partner with them. They can take some of our students. They train them on the dual basic. This one will help to improve the challenges we are facing as a country. Yes, we can create opportunities. Yes, we can create employment. But how are we doing it? We have not done this. So this is the solutions we can use to address our challenges. We can go into look at now the training. Yes, this one from DMG Mori. I'm using this slide for DMG Mori. Actually, when you look at the aspect of changing from one form to another, or one level to another, if we can design our training to have what you call basic package that maybe you can take 3 months. You have intermediate package, you can take like 5 months. You have the expert and the advanced package, we can take, let's say, 6 months to 1 year training, where we can offer one, so first of all, maybe conventional way of machining. There's somebody can advance to learn 3 axis and 2 axis turning, 3 axis milling and 2 axis turning. This is basic knowledge that most of the colleges here in Kenya can do. And then when you go to industries, most of the industries like telecom maintenance, numerical control, Greenable, and other companies I have seen, they have this machine able to do 4 axis and 3.42 or 3.5 axis, or 2.5 axis. If we advance, we can even go to what you call 5 axis and even V6 turning. This one is from Jimori. We can also do what you call field deposition milling, and that is a turning center. twin turret machining. So this one can advance. You see, as you advance, the skills also advances. What you are gaining, you make them as per. And this one can help us to automate our industries. As we now, most companies now in Kenya are producing electric vehicles. How are they making their parts? Some of them are importing. But if we have this level of courses being offered in our colleges, then we are able to offset challenges we are facing as a country. And this one can also help us to create employment. If we go into detail, maybe this one I will not give you for now. I'll just do like basic level. What can we learn in at a basic level, and how many weeks can we design our curriculum? We can have advanced level like CNC turning and CNC milling. From this chart, you're able to understand an advanced what you're going to what are you going to learn. If we look at things like advanced advanced level, for example, for car design, designing for assembly and manufacturing, what can we learn, for example, in this? So if somebody wants to learn all this level 1, level 2, level 3, even level 4, we can do have like 20 weeks to 22 weeks of training. And this is a good training scenario so that people cannot go to a college, they learn business course for 4 years. At the end of 4 years, somebody doesn't know what is a balance sheet, doesn't know how to file returns, doesn't know how to even register business. This is awkward with how we are taking things as a country. Then we need to change our training. We are capable, we can do this one. You can transit one by one. If we check your level that maybe you are a beginner, this one doesn't require you to be an engineer. Yes, we can train you as long as you understand the concept. We can train you, you can start this one basics. We train you on this. Then you advance to basic level. From there, intermediate, expert, then you can either become an employer or an employee. Yes, these are key skills you can transit in our training. And if we offer this one, actually will create more employment opportunities. There are many companies looking for experts, but they can't find, because most of companies in Kenya, they want people who are ready to work. Maybe somebody have money, bought these machines, want to produce parts, but they don't have the expertise on that, and they cannot take you so for a long period to train you. So if we have this one in our colleges or companies offering this one like the Alkis technologies, we're able to offset the challenges that is happening in our industries. Some of the highlights we can check in our training, for example, learning how to do what we call manual part programming. It is good that you need to understand the basic programming languages, things like address, word, blog, part program. You need to understand all this, what it means. You need to understand how you use CAM to automate programming either for ISO dialect or for specific controller, if you're using Siemens controller or Heights for controller, because they have own contour editors. You can also need to look at how do you operate the machine, because operation is very key. Once you understand all this one, you're able to know how to set up to run the machine without injuring yourself and injuring any person or injuring the machines or damaging the machines. You're able to understand how to optimize tools and also cutting parameters, because in CNC Lathe, we have different tools that you need to understand. If somebody gives you DNMG15, are you able to relate the meaning of this? So we'll train you on how to understand the tool identification for both milling and lathe, identify the cutting parameters before you go to the machine. If you want to use either Siemens, Haas, GSK, or Fanuc, then you will also teach you on how to do what we call simulations and virtual programming. We have softwares can do that one, and then also how you can do what we call measurement and quality check. So this is the highlight of our training, what we normally do as the Alkins Technologies. We have some of our graduates like Joseph Karoli, who is now working in MIT. We have experts like Engineer Lewis, who is now working in UK, and others who are now here working in Kenya at Rom Motors, and also in others in Uganda. So maybe we can not offer you so advanced skills, but the basic skills we can offer you is very good for you to become a CNC part programmer or machinist in the industries. So in our next episodes, because we wanted us to bring into you this so that we can be learning all these concepts. So we'll bring you what we call, we'll learn what is interpolation. There are 5 interpolations: linear, circular, helical, cubic, freeform. There are so many of them we can use. We need to understand what is these interpolations, and for each machine, what does it imply. Then we need to understand things like positioning, and also the feed rate. If you're using absolute or incremental, or feed rate per minute, or feed rate per evolution, radius programming, diameter programming, speed functions, if you're using codes which are model or non-model. So we need to understand all these parameters. In our summarized, let me bring to you our summarized program. This is in our summarized program. I want to go direct to our program so that next time we start now writing a simple program. Because this is a simple manual program I did for HNC controllers. I think most of the colleges in Kenya they have this. So if you want to use this one, I can share to you the PDF. You can follow the simple way of setting up, cutting, and programming on that machine. So when I want to summarize this, yes, this one is a very it's a summary. You can do what you call geometric modeling, that is using CAD. Then you choose your machine operation you want to use. From there, you need to factor in what you call let me change the color here. You need to factor in things like the cutting speed or surface finish. Then you assign the spindle and the speed for each operation. Then you do what you call a simulation. If you verify that the program is okay, then you proceed to now, if you're using a software, this is using a software, you proceed to generate the G codes. You load the G code to your either LAN cable or your USB. From there, you bring in the machine, you do what you call workpiece code system setup. Then you verify the program. So if it's okay, if there's no any error, you run, then once it's okay, you run to produce your part. And there are some of the softwares you will be using in our program, like SolidCam, Mastercam, Delcam for Delcam, for that is we normally use it for say woodwork and other softwares that we'll be learning. So in case you want to learn this, this is a simplified method we have designed in our case to help us program the part. Then I will also show you a procedural, some of those things, uh, a simple part program, so that next time I will introduce to you a part program, because this is what we intend to derive our training, so that you're able to understand what is a part program before you now use a computer to generate the part program. For example, our controllers that we have we have 802, this is a typing error, 802, 808, 810. Others we have 828, we have 840, and we have numeric 1. So currently we don't have numeric 1, we don't have 840, we don't have 828D in Kenya. Then other controllers like HNC, which are most courses in our colleges, has GSK and FANUC. So in this simple program, I want to show you what a part program is. Then next time we'll create a simple part program for all those operations like grooving, turning, threading, and all those programs. Like this, a simplified program that I had made for our parts. We'll be using these parts. We have different parts here we can use for our training purposes. Basically, some of them we have produced them. They are in workshops. You can come and see in workshops here at Lunga Lunga. We are located at Lunga Lunga. We can see some of these programs. So I wanted to show you this part, a simple program. So this is what we call a part program. A part program. If you're using GSK or FANUC, normally you find they normally start with this one, 4-digit, percentage at 4-digit. It's a 4-digit number. Then you tool using T0101. If you're using T0101, T0202, those are GSK or FANUC control HNC. But in Siemens, the current Siemens, we're using what you call T. You write T1, then D1. So tool number, tool offset. So I will show you in the next episode what it means. Like this one is a word, and now it's a block. This M03, what does it mean? S900, F100. If I'm using F100 or if I'm using F0.1, what does it mean? I will show you one by one. For each of these codes, we learn the address from A to Z. Then we understand how we can write a simple program, the structure of a program. From there, it becomes easier when I generate a program, we're able to relate what it means by G02, G01, X this, M03, G71. Now this one is a ISO dialect program for HNC, GSK, and FANUC machine. We're using this one, this G71. If I'm using what you call step turning along Z-axis, I use this one called to program. So I will show you all this one in our next episode. when we bring into you how we can create part program for this case. By now, I want to wish you a good night or a good day. For those people who celebrating their day, if you are prepared to sleep, I wish you a good night. Until next episode, we will now bring you what it entails by this um, part program. By this part program. Thank you and have a lovely